Welcome to Brain Vision.
In this problem, we're told that P is now to be is 3A times W. So it's basically the exact same thing as the last problem, but now we have a different value of P here, and then this distributed load is now 4W, 5W, or 5 force W. And so we actually get a, kind of quite a bit different bending moment diagram in this case, mostly because we have a much larger reaction force down here distributed. And so in this region here, now actually this distributed load is bigger than this distributed load because this has a magnitude of W force per length, and this is 5 force W force per length. So now we have a positive slope there. And then over this region, we have this distributed load, and so we have another positive slope, and so we get up here to 1.5 A times W, and these are our peak values here. And so then we wind up jumping 3AW down, so we get down here to minus 1.5, and then again we have a slope here of this value of 5 force W, and then we have a slope here of 1/4 W, and we get back to 0 at the because there's no shear forces acting on the end. And again, there's symmetry here, so we should make sure that we have symmetry in our plots here. And we look at bending moments. Again, there's a distributed load everywhere, so we're going to have quadratic functions in all of our cases. And they look quite a bit different now. And in this case, the peak occurs at the middle. Before the peak, at the middle, the stress was 0, or the bending moment was 0. So now we have, in this region here, we have x squared over 8a squared. So we actually have positive, because before it was negative because this was a negative slope. And in this region here, we have 1/8 all times 4 minus 8x over a plus 5x squared over a squared. So we wind up getting up here to 1. So we have our maximum bending moment is a squared times w. And then we have symmetry over here. I didn't give these functions, but and again we have it winds up at 0 here. So if we compare this to this, we can see we get quite a bit different result when we put a much larger point load at the middle. In fact, we get, instead of a negative bending moment, we have positive bending moment. And now instead of 1/6 a squared times w as our peak, we have 1 a squared times w as our peak. But it's kind of interesting because we increased this magnitude of this load by 3, but we increased the magnitude of the maximum bending moment by 6, and we increased the maximum shear force by a factor of 3.